Visual satisfaction. A 1 mm groove so perfect it looks like a laser-drawn line, carved with less than 0.01 millimeters error on a steel bar. Watch the CNC mill achieve this impossible precision in real time. Deep inside the Bengaluru facility, the 1 mm CNC mill hums, its spindle poised over a gleaming steel bar. Engineers claim it can carve a perfect 1 mm groove with less than 0.01 millimeters deviation. How does the tool tip stay within that razor-thin band? The answer lies in a hidden laser sensor, but that's just the beginning. Inside the control room, a green laser sweeps across the tool holder, measuring position every 0.002 millimeters at a staggering 500 times per second. The data streams onto a glass screen, flashing green numbers that never exceed 0.009 millimeters. Here's what nobody is telling you. This relentless feedback loop trims error faster than a hummingbird's wing. But the real test is about to start. The camera slows to 0.1 times speed as the cutter tip kisses the steel, carving the first millimeter. You can hear a faint whine, like a distant violin, as the metal yields. But here's where it gets really strange. Each microgroove aligns perfectly, forming a line so straight it seems drawn by an invisible ruler. Yet the journey has only just begun. I watch the tool glide, inch by inch, as the groove stretches to 30 centimeters without a single wobble. The sound shifts to a steady hum, like a train on rails, while the laser readout steadies at 0.008 millimeters variance. Watch this moment. It's impossible to look away, because every millimeter proves the machine's unwavering precision. Still, the final reveal hides a deeper secret. The camera pulls back to reveal a full meter steel bar, its surface polished to a mirror shine. Along its length, a flawless 1 mm groove runs, measured at a consistent 0.009 millimeters variance from end to end. This single number proves the mill's claim, sub 0.01 mm accuracy across a whole meter, a feat only 3 factories worldwide have achieved. But the story doesn't end here. Next, a human hair, averaging 0.075 millimeters thick, lies beside the bar. The laser scans both, showing the hair's surface wavering by plus or minus 0.012 millimeters, while the machine groove stays within plus or minus 0.009 millimeters. Did you expect a strand of hair to be more accurate than a high-tech mill? The data tells a completely different story, flipping assumptions on their head. Yet there's more to uncover. In aerospace, a 1 mm tolerance error can shift a turbine blade by millimeters, causing a 23% loss in efficiency. Engineers now source these grooves for jet engine combustors, where the flawless channel directs fuel with laser-like precision. Imagine the roar of a jet calming as the fuel flows through a perfect line. This is why the mill's accuracy matters beyond the shop floor. But what does this mean for other industries? The mill itself carries a price tag of 2.5 Indian rupees crore, yet its precision cuts scrap by 18%, translating to annual savings of roughly 47 Indian rupees lakh for a typical production line. That figure dwarfs the initial outlay, proving that investing in micro-accuracy pays off faster than most think. But the ripple effect reaches far beyond cost. Most factories believe sub-0.01 mm tolerance is impossible without cryogenic cooling, yet this mill proves otherwise. The science behind why this is so satisfying lies in the laser's closed-loop feedback, eliminating thermal drift in real time. Watch this moment. The laser flickers, instantly correcting a deviation before it even appears. This changes the whole industry narrative. And the next chapter is already being written. To replicate this success, a plant must first install a 5-axis laser interferometer, then calibrate each spindle using a 0.002 millimeters reference rod, and finally program a 0.01 millimeters tolerance check after every 200 cuts. The process feels like tuning a grand piano. Each adjustment echoes through the entire system. And that's where most people miss the crucial step. Since 2021, India's precision exports have risen 23% year-over-year, with this mill accounting for 12% of the total increase. Could this spark a global shift toward Indian-made microcomponents? The data tells a completely different story, showing that nations now prioritize submicron accuracy over sheer volume. Yet the next breakthrough is already on the horizon. With the mill's precision now proven, manufacturers across India are retooling, aiming for submicron tolerances that were once science fiction. The ripple effect reaches medical implants, where a flawless 1 mm channel can mean a life-saving fit. Let that sink in for a second, because the next chapter of micromastery is about to begin. We cover the stories Indian media buries, the fraud, the data, the real numbers. If you want the next precision breakthrough the moment it drops, hit subscribe and the bell right now.